So hello friends, today's question is whether a BJT is same as that of a JFET. Well, both are very important electronic devices which are very popular. So let us try to understand the difference between a BJT and a JFET. So a BJT stands for Bipolar Junction Transistor, whereas a JFET stands for Junction Field Effect Transistor. So that means both are transistors, but what is the difference between them? So if you just look at the cartoonic representations of a BJT and a JFET, you will very clearly find the difference that both of them in appearance are not similar. So let's try to understand the difference between them. So to start with, BJT stands for Bipolar Junction Transistor. So the word bipolar means the current that flows in a BJT is due to both electrons as well as holes. A BJT is a three-terminal device and the three terminals are base, the collector and then the emitter. So BJT has three terminals and there are two variants in a BJT. One is NPN and there is also another flavor called PNP transistor. So if a BJT is of NPN type, that means the emitter and then the collector will be of N type, whereas the center layer, which is the base, will be of P type. So let us try to understand how a BJT works. A small base current IB controls a much larger collector to emitter current IC. What does it mean? So if you just look at this particular cartoonic representation, you can very clearly see that there are three layers. So this is N type emitter, this is P type base and this is N type collector. And the three terminals are base, collector and then the emitter. So here base terminal actually controls the current that flows from the collector to the emitter. That means the base is the control terminal, or in other words we can also say that a BJT is a current controlled device and that current control happens at the base terminal. Okay, fine. Now BJT can act as a switch, it can also act as an amplifier. And with respect to symbol, this is how a BJT looks like. So if we look at the current components of a BJT, well, there are three current components: base current, collector current and then the emitter current. If we apply KCL, then it is very clearly observed that the emitter current is equal to summation of collector current and base current. Next, junction field effect transistor. First of all, JFET is a voltage controlled device or a voltage controlled transistor. The three terminals of a JFET are gate, drain and then the source. So from where to where will the current flow in a JFET? The current flows from drain to source. And which terminal actually controls this current flow? Well, it is the gate terminal that actually controls the current flow. Now, are we applying a current to the gate terminal or are we applying a voltage to the gate terminal? Okay, so here it is the voltage that is being applied to the gate terminal that actually controls the drain current. So that means gate is a control terminal, or in other words we can say that a JFET is a voltage controlled device. Okay, now how does it work? Well, if you closely observe again the cartoonic representation of a JFET, it's very clearly observed that this green colored shaded region is N channel, and the gate which is tied to both the sides is of P type. So again in a JFET there are two variants, N channel JFET and P channel JFET. So this particular diagram represents a N channel JFET, which means the current is mainly due to electrons, not due to holes. So that means a JFET is a unipolar device, unlike a BJT that is a bipolar device. Okay, fine. Now how does it work? Well, the gate is reverse biased by a voltage VGS. This changes the width of the channel. So as the magnitude of the gate voltage goes on increasing, the channel becomes narrower and narrower. That means more negative is the gate to source voltage, narrower will be the channel. And as the channel gets narrower and narrower, the drain current's magnitude goes on reducing. Okay, so what about the key relationships? Well, we can say that the drain current ID is mainly controlled by the gate voltage or the gate to source voltage, which is VGS. So as VGS becomes more and more negative, ID decreases. Now, one important concept to be understood here is the voltage that is being applied to the gate, it results in an electric field that gets established between the gate and then the channel region. That means it is purely a capacitive effect. So it is this capacitive effect that actually makes sure that the electric field is established, and due to the electric field, the capacitive effect is always present. Now, as the drain potential keeps on changing, so does the current also change in a JFET. So it says change the gate voltage and the drain current changes. So this particular symbol represents a N channel JFET. Now, what are the uses of JFETs? Well, JFETs are used as switches. They are also used as amplifiers, but most importantly, they are being used as constant current sources. So now to put it in a comparative analysis, well, BJT versus a field effect transistor. So a BJT is a current controlled device, whereas a JFET is a voltage controlled device. So the primary differences between a BJT and a FET can be put up as such. BJT, it's a bipolar device. FET, a unipolar device. The three terminals of a BJT are emitter, base and collector, whereas the three terminals of an FET are gate, source, drain. A BJT is essentially current controlled device, whereas a JFET is essentially a voltage controlled device. The input impedance of a BJT is comparatively lesser when compared to an FET, whereas for an FET the input impedance is extremely high, which is usually in mega ohms. Now to talk about voltage gains, a BJT can provide very large AC voltage gains, whereas a JFET comparatively provides a lesser AC voltage gain. Now to talk about stability, BJTs exhibit average stability with respect to temperature variations, whereas FETs are more temperature stable. So that means when it comes to stability aspect, we can prefer FETs. And finally, BJTs are older devices and they are bulkier, whereas FETs are usually smaller when compared to BJTs, and this is the very important advantage of an FET that enables them to be used in integrated circuit chips. So we normally see field effect transistors being used in integrated circuit chips rather than BJTs because they are bulkier. However, it all goes with the end user application whether to choose a BJT or an FET. So finally, to summarize, is a BJT same as that of a JFET? The answer is, well, both BJT and JFET are transistors. So they can be used as switches, they can be used for amplification. But their behavior is completely different while their purpose is the same. Thank you.